Then we did the squat jump, which is start from bend and then jump up, so 135 degrees and 90 degrees, 45 degrees, 90 degrees and 45 degrees wide. So we did the 3 counter movement jump, CMJ, the 45 degree static jump, and used the goniometer to measure the joint angles, and the 90 degree static jump. So there were 4 phases of this, but before this we had to do preparation, so a PAR-Q completion, just to check they're happy to do it and know what's happening, so that they can't sue you for anything. Completion of protocols, so safety protocols, check like heart rate, etc. Warm up to make sure they're ready to do it and don't get injured, and informed consent so that they then can't sue you if anything goes wrong. So during the squat, the quadriceps contract or lengthen. There's the eccentric movement, then the quadriceps shorten, which is concentric movement. So there's the sampling frequency is how many measures are taken per second. So the more samples you take, the more valid your data will be. So our frequency was 1000 Hertz, which is really good, as the Kistler Force program measures at 1000 Hertz. There were 4 phases, as I said, there were 4 phases, which were unweighting, braking, propulsion, then time in air. So we had to do quite a few familiarization jumps, but I'll come on to that in the evaluation. So to film it, we needed to make sure we had the right camera settings, the right height, right distance from the performer taking part, the correct angle to get the right footage, and the right plane of motion. So we needed the right camera settings, so as I said, for sampling frequency, the right shutter speed, focus and iris. So to look at angle changes, we needed a higher frame rate or frequency to get more detail on the shot. So for frame rate, the amount of single frames, this is the amount of single frames that compromises or makes up your whole video per second, so FPS. Frames per second is measured in hertz, and you can get super slow-mo, so which can be done on high-speed camera, which is 1000 per second. So shutter speed, you can make the footage jumpy or blurry, so the lower the shutter speed helps makes motion blur, which stops the footage from being too jumpy. So if the shutter speed is too fast, the lighting can be bad and you won't be able to see the footage well, and it will be unusable for your inquiries. Dartfish allows you to talk through the image on your phone, and allows you to put images side by side or footage side by side, so you compare two people or compare different jumps or to an elite performer, and you can share feedback with performers without them having to look at the same screen as you, so it doesn't take up as much time. However, it is quite expensive. So you need joint markers when you're doing this, so it makes it easier for the person watching it to look at the angle of your joints. So the joint you want marked at your shoulder would be your anterior lateral aspect of the acromion process of the scapula. At the hip, you'd want the 3 cm superior to and 1 cm anterior to the greater trochanter of the femur. At your knee, you'd want the midpoint of a line through the centre of the posterior convexities of the femoral condyles. And at your ankle, you'd want the most distal palpable point of lateral malleolus. And at your toe, you'd want it on the top of your shoe, adjacent to the 5th metatarsal. You can mark this on someone using marker pens, or make a cross using tape, or specifically zinc oxide tape. So other camera settings that you need to take into consideration would be the focus. So does it do it automatically, or do you need to set the focus to the right amount so that you're obviously not out of focus and the footage would be blurry and unusable? You need the right lens so that it has the right zoom and the right focal length, so you're not really close in and can't see all the joints, or you're not too far away so it's hard to like focus in on the joints. You need the correct iris, which is the amount of width that you get when the aperture opens. So then when you position the camera, you need to consider, does it cover all the planes of motion, how far away it is from the subject or the person performing, the angle that the camera is at for the footage of the performer, so is it in a good place because it captured all of the performer, so also what is viewable from the camera, so whether it gets the entire motion of action, the height of the camera and the width of the shot, so do you need it quite wide to capture the whole performer, or do you need it at level with the performer so you can capture everything that he does, and the image size. So when you physically put the camera up with the tripod, there's 4 things: triangulation, pan, tilt and roll. So the spirit level needs to be in the middle so that the camera's not tilted to one side, and you need a 3, 4, 5 triangle so that the camera can pan across each side. There is a horizontal plane which allows it to roll, and an elevation plane which allows you to pinch or tilt the camera. You can use the stick on the tripod to turn the camera each way if you need to move it slightly so you can get more of one side's footage. There are some principles of recording. So these are to make sure the image size is within the field of view. To be careful because the action has motion, and the performer needs to be in the shot. Perspective error. This is the distance between the performer and the camera. So they could go out of the plane of motion while doing the skill. If the performer's behind the plane of motion, then they'll look smaller, but if they're in front of the plane of motion, then they will look bigger. So performers, then you'll get the height wrong, because if the performer is not in the plane of motion, then you will measure the height wrong. But this can be reduced by increasing your distance of the camera from the plane of motion. So try and get the camera as far away from the plane of motion as possible. But angles are unaffected by the distance between the camera and the plane of motion. Rotation out of the plane of motion causes the angle of your knee to change or get smaller, for example. Movement parallel to the plane of motion does not affect measurement angles at all, and rotation out of the plane of motion affects both lengths and angles. The implications for having poor method are that your data collection methods won't be correct. The video could be bad images that are unusable, so therefore your video analysis isn't very good, and your results are actually incorrect because you've judged them wrong because your footage was bad. The evaluation of the actual jumps is that it took several familiarization jumps to combat landing not on plate and using your arms, so therefore next time you could have even more familiarization jumps, as when we were doing the actual jumps we were still trying to get used to doing it, and it's not that realistic, as we lose the natural setting by doing it in a lab and not on a court or something like that. And some were done by photo and some were done by video, so therefore it could be caught in 3D by using Vicon advanced data. When you set up a camera, you need to use a reference point like a meter stick, so the software knows the scale of it. And some things are quite hard to capture because they can be in many planes, like a cricket bowler, for example, because there are lots of different movements. So horizontal scaling. Greaves in 1995 said, this frame refers to the complete image captured at an instant in time. Therefore, frame rate or sampling frequency are the full images that are captured every second or per second.